In this question, we want to explain how a DC motor works using these following words. So our battery has a positive side and a negative side. We call that negative side anode and the positive side cathode. You can remember that the T in the cathode is like a positive side, the N in anode is negative. Okay, so let's see what happens if you put an electron right here. There's electrons in these wires. So which way are the electrons going to move? Here we've got a negative side, an electron current is going to move away from the negative side. Here we've got an electron on a positive side, it's going to be attracted to the positive side. So we get a current that moves in this direction. Now let's follow it along. It goes this way, then it follows along. So at this point it's going to be moving to the left, wraps around, and at point C it's moving to the right. And it's moving back to the left at point D, and it goes back to the cathode. Alright, how is this going to cause the motor to spin? Well, we also have a permanent magnet right here. Now whenever you have a permanent magnet, there's a north end and a south end, and we can say that there's magnetic field lines that are created from that permanent magnet. And they curl around just like this. They come out from the north and they go back in to the south. Okay, so if we look what's happening here, we've got magnetic field lines. Now they're going to curl around and come back. But the important part is that in this area, they're moving up. That's the part that we care about. Around C and around D, they're moving up. So we have this rule. It's the right-hand rule. And it tells us if we have current in a wire, which we do, this wire right here. We also have a magnetic field, which we have from the permanent magnet. We're going to have a force on that wire. And this rule tells us which direction that force is. Okay, so let's look at point C. At point C, we have a current in the wire moving to the right. So using your index finger, point your index finger to the right. Then we have a magnetic field up, which is created from this permanent magnet. We have our magnetic field up. So you should be pointing your index finger to the right, your middle finger up, and what you're going to find is your thumb should point towards you. If we look at point D, it's a little different. This is point C, and the force was towards you. At point D, we have the current moving to the left. So this is your index finger. Then we've got the magnetic field. It's also pointing up from this permanent magnet. Use your middle finger for this one. So we have index finger to the left, middle finger up. This one's pretty difficult to try yourself, but the force is going to be away from you or into the page. Alright, so let's look at these 2 points. At point C, there's a force that's towards you. At point D, there's a force that's away from you. So picture someone pulling at point C, because it's towards you. Someone's pulling it towards you, and at point D, they're pushing it away. This is going to cause a rotation. C is going to come towards you, D is going to go away. And it's going to flip around, and again, C comes towards you, D away. C towards you, D away.